Good evening, class. My name is Hassan, and this is my presentation for AppArmor and HTTPS. I'm going to begin with what's AppArmor. AppArmor is a kernel enhancement to confine programs to a limited set of resources. AppArmor unique security model is to bind access control attributes to program rather than to users. AppArmor protects operating system and application by enforcing set of rules based on each application. AppArmor has two modes. The first one is enforcement and the second one is complaint mode. I'm going to start explaining what's enforcement mode. So in enforcement mode, all profiles are loaded in enforcement mode, and this will result in an enforcement of policies, defining in profiles as well as reporting policy violation. The other mode is complaining mode. In this mode, profiles are loaded in complaint mode and it will not enforce policy. Instead, it will report policy violation attempts. And this mode is very convenient for developing profiles. In Ubuntu, AppArmor is installed by default, confining application to profile, determining what file or permission a program needs to access. In this slide, I'll go over AppArmor technical details. First, I'll start with security model. AppArmor is a complete kernel level mediation through Linux security model. AppArmor is a proactive whitelist approach, meaning that no attack signature database. AppArmor profile grant access to the minimum list of files and directories and POX capabilities required by the application, meaning that whenever a protected program runs, regardless of the UID, AppArmor controls it. In this case, the POSIX capabilities can have even it's running as a root, and directories and file can read and execute. Other technical details are automated flow, and this will be like auto-generate in creating profiles, auto-scan, application listening to open network ports and check for existing profile, auto-generate creates files and based on statistics, that's the auto-generate, and the auto-learn mode that will automatically expand profile while running the application through the normal operation. And last is interactive optimizer, which suggests best rules and assists in simplifying profiles. In this slide, I'll go over AppArmor commands. The following are example of AppArmor commands. So if you want to put a profile in complaint mode, you will use sudo aa-complaint. And if you want to put a profile in enforce mode, then you use sudo aa-enforce. If you want to list the current status of AppArmor, you use sudo aa-status, and if you want to reload all files, you use sudo service AppArmor reload. Next, I will discuss about hardening Ubuntu Linux 18.4. Make sure you use strong password and disallow SSH password authentication. Make sure you disable password authentication and make sure its value is set to no. And if it's set to yes, you can still use password to log in. You need to use authentication key pair to log in. And this is by default. You log into your system through SSH with a username and a password. And if you haven't set a strong password, that can be open door to hackers. And remember, malicious people use bots that try to brute force your password. And this can be extremely dangerous. You need to create a backup configuration file. It's always a good idea to make up a backup of any configuration files before editing them. You also need to create a non-root user with sudo privilege. Make a habit of logging to your Ubuntu server using a non-root account. This will prevent the accidental deletion of files if you make any mistakes. In this slide, I'm going to discuss adding AppArmor. Make sure you reboot after installation and start your system properly. Most Linux users, especially admin, depends upon the command line to perform frequent tasks on Ubuntu, and one task is rebooting and restarting your system. We tend to restart our system for various reasons, and one of the reasons is because some software require rebooting at the end of the installation so that it can become fully operational. Some configuration changes on Ubuntu also require you to start your system so that the processes are updated accordingly. There is another reason to reboot your system that we can ignore, is getting rid of a software glitch. Whenever we restart our system, a fresh copy of software is loaded into the active memory, getting rid of the malfunctions one. We also need to make sure that all our service applications that we want to put policies on are running, and all our changes are taking effectively and running properly for each service and application. If you don't update the system right after installation Ubuntu, you might face issues while trying to install a new program. We also need to monitor application and framework and make sure the right policies is implemented. Next, I'm going to discuss HTTPS. HTTPS stands for Hypertext Transfer Protocol Secure. It's a secure version of the HTTP protocol that uses the SSL for encryption and authentication. Because HTTP was originally designed as a clear text protocol, it's vulnerable to eavesdropping and man-in-the-middle attack. So HTTPS mitigated this vulnerability by piggybacking the HTTP protocol on top of SSL so that all messages are encrypted in both directions between two network computers. Example, a client and a web server. The HTTPS URL begin with HTTPS / instead of HTTP // Modern web browsers also indicate that a user is visiting a secured HTTPS website by displaying a padlock symbols to the left of the URL. Because data can be sent with or without the use of SSL, one way to indicate a secure connection is by the port numbers. By default, HTTPS connections use TCP port 443, and HTTP use unsecure protocol port 80. This slide is the continuation of HTTPS. So SSL operate directly on top of the Transmission Control Protocol, TCP, effectively working as a safety blanket. It allows higher protocol layer to remain unchanged while still providing a secure connection. So underneath the SSL layer, the other protocol layers are able to function normally. The Transport Layer Security, TLS, this is the successor protocol for SSL. The TLS is improved version of SSL. It works in much the same way as SSL, using encryption to protect the transfer of data and information. The two terms are often used interchangeably in the industry, although SSL is still widely used. Lastly, depending on what level of validation a certificate is given to the business, a secure connection might be indicated by presence of padlock icon on a green address bar. In this slide, I'll go over importance of HTTPS. First, it protects users' privacy, like confidentiality, by encrypting traffic between your browser and server. It also tells you who is behind the curtain. With HTTP, you will never know who's behind the curtain, but with HTTPS, you will know. Also, it provides authentication, like you will know who you're talking to. It also protects your user and your business from evil website and manipulation. It also provides integrity, like is this what somebody say or no? In this slide, I'm going to discuss hardening HTTPS. First, we need to create public keys for web server allowing HTTPS connections. We need to encrypt and provide SSL/TLS certificates. This will provide extra layers of security if confidential or sensitive data is exchanged over public internet. Also, look to see if your web address begins with HTTPS. If it doesn't, please don't enter any sensitive information like your credit card. Make sure you keep your software updated, and make sure you manage use and admin account, ensuring all your policies are well followed. Last slide is my references, and this concludes my presentation on AppArmor and HTTPS.